X and Y are positive real numbers, satisfying that x cubed plus y cubed is equal to their difference. Show that x squared plus 4y squared is less than 1. When we look at this problem, we see that we are comparing an algebraic expression against a constant, which is 1 in this case. So in this type of problem, we're going to use a technique called homogenization. This is when we can use what we know to try to rewrite the constant 1 in terms of a rational expression. Before we do anything, we always have to look at the domain. We know that x and y are positive because the problem tells us so. This means that x cubed plus y cubed is also positive. So then, because these two expressions are equal, x minus y is also positive, which tells us that x is greater than y, which is greater than 0. Okay, so now we have our domain settled. Now let's go ahead and homogenize the inequality. How can we re-express this 1? Well, because we know that this expression and this expression are both equal, it means if we have x cubed plus y cubed divided by x minus y, this would equal 1. So we can rewrite 1 as this rational expression. Now all we're going to try to do is prove that this inequality, this new inequality, is true. Because we know that x minus y is positive, we can go ahead and multiply x minus y on both sides. Now let's expand the left-hand side. We have x cubed plus 4xy squared minus x squared y minus 4y cubed. It's less than x cubed plus y cubed. Let's combine like terms. We're left with this inequality. And because we know that y is positive, we can go ahead and divide y from both sides. Now, how can we finish this proof? This is where the AMGM inequality comes in. Let's first move the negative x squared to the other side. That way, we don't have to deal with negatives. We're going to apply the AMGM inequality. We know that this 5y squared can be split up into y squared plus 4y squared plus x squared. Now we can apply the AMGM inequality on this part. If we have x squared plus 4y squared, according to the AMGM inequality, it's going to be greater or equal to 2 times the square root of 4x squared y squared. This is the same thing as 4xy. So we just proved that x squared plus 4y squared is greater or equal to 4xy. Right now we have the x squared and the 4y squared, but we still have to add on a y squared. So if we have the x squared plus 5y squared, we're going to add on the y squared, is greater or equal to 4xy plus y squared. And because we know that y is positive, we know that y squared is also positive. It cannot be 0, which means that when we have this inequality, the equality can never hold true because y is always positive. So x squared plus 5y squared will always be more than 4xy. It cannot equal 4xy. So now that we have proven true this inequality, if we trace back our steps to what we started off in the first place, this inequality came from this original assumption. So if this result is correct, then it means our original assumption is correct. And that's it for this video. In this video, we used the technique of homogenization, where you rewrite a constant using the variables that you know.